knowledge of your DevOps will be judged based on how well you know how to deploy your application. The applications are not very simple. The applications are microservice based. Okay. So in that case, if I know Kubernetes very well, I can get a job easily. Not easily, maybe given the conditions of job market today. But generally, a person who is going to get a job is expected to know Kubernetes very well. Okay. Otherwise, getting a DevOps job is also earlier, say almost 2 years back, it was like DevOps job. Even if you didn't know Kubernetes was available, but now you need to have a good knowledge on Kubernetes. So with that context in mind, with that particular objective, we need to learn DevOps, Kubernetes, particularly in DevOps. Okay. Any questions you have before we start? Do you have any questions before we start? Okay, great. So let me share my screen. Today I have some technical issue with my video, so I will not be able to share my video, but definitely the audio, I think the audio is audible to you. So we will continue with the audio only. Let me know if you can see the screen.
Yes.
Okay, great. So basically, what we have done is on the previous session, we had learned about all these things, a definite flow of how the control plane, the master node, communicates with the worker nodes. There can be worker nodes 2 in number minimum, or maybe more than 20, more than whatever. So one master node, generally the thumb rule is, can control, you should not make it more than 40. But so if you have 80 or 60 nodes scattered all over the world, which will be serving as your uh, nodes, which will host your application as pods, you will remember that you need at least two control nodes or master nodes, two master nodes. One will not be sufficient if you have 60 worker nodes. So the thumb rule is 40 maximum per master node. And we have also discussed about the flow. If you remember, if you have gone through my earlier video, you will see that we have seen a very detailed diagram, a very detailed workflow, how it happens between. Oh, did I start my recording? Just 1 minute. I didn't start my recording. Sorry. Okay. The recording has started. So I can just repeat a bit what we said. So what I was saying, we have this particular diagram. So earlier we have ended up the previous session with this diagram, just to give a very detailed knowledge of how the data and how the master node controls the worker nodes and what is that it controls. Okay, all the communication between the API server, the HCD, scheduler, controller manager through the kubelet or of the kubelet of worker nodes. Okay, with the help of kubeproxy. So if we had explained an example of when one pod or one container gets down, how this is quickly replaced. Suppose you have a deployment which is saying that you have three replicas of the same application over three nodes, over two worker nodes. So maybe there are two pods over here and one pod over here, or maybe there is one pod over here and two pods over here. They are having the same application and they are replicas. So if one of the pods get down, what will happen with how this pod is now, because my desired state is to always keep 3 in number. That means I have deployed with the intention that there will be always 3 pods of that application available or replica. So a replica set when you have declared or deployed as 3 will always remain 3. If there is a drop of one of the pods, what will happen? How the flow is managed, that we have already discussed. I don't think we should be discussing it again because we have already done that in our previous video. So let us go to the next slide. It is the same architectural view. Are you being able to see the screen?
Yes.
I mean, no, will it help if I make it bigger? The full screen? Let me do that. Does it help? Right? So we can have a bigger view. So in this, what we are trying to understand is like this is our, what is this? This portion. What about this portion? This is the control node or the master node, right? Control plane, where you have the API server, HCD, controller manager, scheduler. These are the 4 main components of the master server, of the master node. And there is a component called kubectl that will also come under installation. Kubectl is the CLI. You know CLI, right? CLI is the command line interface. So you must be writing as a Kubernetes administrator or a Kubernetes DevOps guy who knows. So you must be instructing or writing something, making some management of, you are giving some instructions to get some results. You are querying the state of these pods, of these various applications in various nodes. So how do you manage it? How do you understand that? You have to learn some commands. These are called kubectl commands. Kubectl. Either somebody says kubectl or you can say kubectl. Kubectl is a part of Kubernetes. It is a tool of Kubernetes which helps you to interact with the master node. And through the master node, you will be interacting with the worker nodes. Are you getting me? See, whatever instructions you give, you cannot give it directly over the node 1 or node 2 or node 3 or node 4. Any worker nodes will not respond to your query. The kubectl will only request or query from the API server or on the control plane. You give your, see, everything will come to API server because that is the heart. Then this API server will decide whether I need to get some information from HCD because HCD is the database which stores all the information scattered all over the nodes or in the entire Kubernetes architecture in the cluster. Or I need to, some pod is down, so the API server needs to go there and rectify it. Or you want to deploy one more application with 3 replica sets or 5 replica sets or 10 replica sets. What you need to do, you will take the help of our API server through the kubectl will deploy something, and that deployment comes to this. You will basically write a deployment file. Okay, we are going to discuss that. Don't worry. A manifest file which is going to be executed through the kubectl, and that manifest file will be executed or processed over by the master node. And with that deployment, you are going to deploy the pods over the nodes and distribute. So API server will use that manifest file to use the scheduler and the controller manager and HCD to deploy the pods. Okay. So see, all the instructions are coming through the kubectl to the QAPI server. QAPI server will do the needful after that. Whereas, again, any communication that should happen between the nodes, worker nodes and the control plane should also happen through the API server. Anything will go out from the API server and anything will come into the API server. Yes, you can say there is a controller manager in between the worker nodes and the API server. Yes, there will be, because everything coming in or going out is through the controller manager. Okay, but everything will only depend on how the API server is going to ask these other components to work with. Any questions at this point? What is this between your user and your cluster? What is this? And why is this? This is called load balancer, right? Why is the load balancer? Can somebody just give a concept of why we have a load balancer over here? Here in a simple network architecture like this, where there are two nodes and maybe very few pods, do I need a load balancer? In that case, I do not need. But as your application grows or lots and lots of microservices applications are implemented in your system or deployed over the Kubernetes architecture or the Kubernetes cluster, there could be a need. And as your applications get popular, okay, there will be lots of users trying to get hold of your applications scattered all over all the nodes controlled by the master plane over the Kubernetes cluster. So there could be a need of a load balancer. What will load balancer do is to distribute the load between the nodes. Because if you do not have a load balancer, you cannot direct or distribute the load between the pods or the or the nodes distributed all over the cluster. So the load balancer has a round robin logic. It has an algorithm. It knows how to find out where it should distribute redirect the traffic to. So generally the affinity or the usefulness of a load balancer is to determine which node or which pod is least busy and take that request. That intelligence is inbuilt within the load balancer. So you may implement a load balancer, but that load balancer can come from the EKS or AKS, though those are the cloud provided load balancer, or you may implement your own load balancer, and we are going to learn this today. At least have an overview of that load balancer. That is, we are going to learn. So ingress nginx controller. We are because these load balancers that are provided by the network or cloud can be a bit costly. To avoid that cost, most of the companies, what they do, they will hire you because you know how to implement an ingress controller instead of a load balancer, because ingress controller won't cost you, whereas a load balancer can cost you a lot money. So as a person who will be selected, who can save some money for the company, and you are that person because you know how to implement your ingress controller. We are coming to that topic. So this is, can you understand this well now?
Yes, sir.
Just I get some calls often, so sorry for that disturbance. Just give me 1 minute. I will just respond. Okay, sorry. So you see, this is a single view. So there can be an interface of cloud provider API, which is, can you tell me which one is that API or which one is that is being talked to with the cloud controller manager? We have discussed that, the full SaaS. So sometimes you may go for the native implementation of a Kubernetes architecture, or you may go into taking a help from the cloud provider like Amazon or Azure or Google Cloud platform. So what is that called? If you are using AWS, it is called EKS, Elastic Kubernetes Service, or for Azure, it is called Azure Kubernetes Service. That is a part of implementation of the cloud, which takes majority of the management functions of Kubernetes. You do not need to implement it from the core of it and native, and you do not have to administer it. Administration, management, everything will be taken care of this. But then it has to interact with the cluster. There is a fifth element. Apart from API server, etcd, controller manager, scheduler, you have a cloud controller manager because you have implemented EKS or AKS. Okay, so your cluster will take help of cloud controller manager, okay, which will interact with your AKS or EKS. So there is a fifth element, component. Otherwise, the rest four are remaining the same. Kube controller manager, which is this controller manager, scheduler, this scheduler, kube proxy. Yeah, proxy will be there because it is, after all, there will be a pod network, and a pod network will only work when there you have a kube proxy. And there is the API server. And also you will see there will be kubelet over on the controller plane as well as on the worker node. And the kubelet will work on the controller node or on the worker nodes. It will interact with the pods or the container runtime. Here also there is a kubelet, and it will also interact with the container runtime, that is Docker, mostly Docker. It not necessarily it has to be Docker. It can be some other container management tool, but mostly Docker is very, very popular. So that container engine has to be installed over in the controller manager as well. I mean, not controller manager, sorry, the control plane, master node, and as well as the Docker has to be, or the container management software tool has to be installed on the worker node as well, because the kubelet will talk to the Docker container or the container runtime to manage the containers or the pods. Here also, these are all pods. So you must have your kubelet to manage these pods. Okay. Is there any question up to this? So there are two external interface. One is kubelet, kubectl, kubectl, which will interact with the API server. Can you see from everywhere you are connecting to the API server? From API server, then it will all go and do as part of the processing done through Kube API server. Any question up to this? Any question up to this point? No, right? So can I proceed?
Yes, sir. Yes, sir.
Please let me know whenever you are getting some conceptual constraints or issues. Now, coming to the components. So what are the components that we have discussed? If there is a cloud implementation of the Kubernetes, either EKS or AKS, there will be a cloud controller manager. So sorry, this should be cloud controller manager. There is also a controller manager, which is the core component of API server, etcd, scheduler. They will interact with the API server will interact with the kubelet. Kubelet will interact with the kube proxy. And there will be each a combination of kubelet and kube proxy for each of the worker nodes. Right? Apart from kubelet and kube proxy, what is the other component? Not Kubernetes component. There is some other component which must be there, both over here as well as over here on each of the worker nodes. What is the thing that you have to install? Just now we have discussed. Without which a kubelet cannot manage the pods. What is then required? On each of the nodes and even on this Kubernetes master? Anyone? Just a wild guess. Not even guess. You just knew it just one slide back.
That is CLI.
You need your container runtime. Both. This is the common part. Container runtime has to be there. That is the Docker. I'm into say Docker. Docker needs to be on the control plane as well as on the worker nodes. So you need Docker to be installed on each of the nodes. Like you have to install the kubelet, kube proxy on each of the nodes. And there will be a pod network between the cluster. So all these things are part of the installation. Installation of Kubernetes is one of the toughest jobs. But while we learn, a person who has no concept of DevOps, they learn towards the end of when we learn Kubernetes towards the end, they learn it. You won't believe how easily that one of the toughest topics of DevOps, which is to install Kubernetes cluster, they learn it easily because we groom them step by step. And when they reach at that stage, when they learn Kubernetes, they are already has become some sort of a champion, some sort of an expert. So I will not discuss installation. Installation is it will take itself, like in our paid sessions, we generally take almost 2 sessions, 2.5 hours each session, almost 5 hours we'll take to learn installation. Not simple. We do installation 2 ways. One, the native installation, that you do everything from scratch. And another one is when you have to do an installation over EKS or AKS. When you have the cloud managed Kubernetes services. So there are 2 types of installation. One, you do the native installation, and the other one, you do the cloud installation of Kubernetes. Okay, both we learn. Anyway, I will not go into that topic. So anyhow, you have installed all these pods, kube scheduler, etcd, kube API server, controller manager, cloud controller manager if you have EKS or otherwise not. This is optional. And of course, you install kubelet, kube proxy, and Docker in all of the nodes as well as in the master node. Okay. And another thing is you install a pod network that is from Calico. Okay, Calico or WeaveNet. These are the 2 very, very popular topologies that are followed in this domain of Kubernetes. That is, you install the the pod network, either Calico pod network. Pod network means the network through which the pods will communicate between each other, the nodes, or between each other, or between the worker node and the control node. That there you need a network manager, and that network manager is either from Calico or from WeaveNet. So we have 2 types of either of them, though both are very, very popular. So Calico This is one very popular. And in our classes, in our sessions, we learn about ViewNet. But both the functions are the same. Both have a purpose to install pod network. Okay. So to install the pod network, we need either some mechanism from Calico, this is the vendor, or ViewNet. Is that clear? So there will be a pod network running between. So if I say so this is a pod network. So wherever there will be nodes joining the cluster, the pod will be automatically, you do not need to install. Say today you have one master node connected to two worker node. These are worker node, and this is the master node. So this is a cluster of Kubernetes. Tomorrow you wanted to add one more node tomorrow, and maybe day after another node. So that way your cluster will keep on expanding. But the question is, this is an interview question. For each of the node added, do you need to do some management of the existing pod network, or the pod network is such dynamic that it already knows that there is one more node which has joined the cluster? Joining the cluster means joining a node is being able to talk to the master. That is called joining. So it is called cluster bind role, whatever it is. So I will say it is joining this worker node is joining the master node through some mechanism. But the question was whether you need to do some management of the pod network, or will it automatically understand that there is a third node third worker node which has been added, and therefore it will extend its the network node, the pod network, to embed or to be functional with this particular worker node? What do you think? Yes.
Like basically we need to.
It is dynamic.
It's a token.
The Calico or the Vim network or the pod network is dynamic. Is very, very dynamic. That means you do not need to install the pod network again and again for each of the elements that are getting added or joined to this network. Is that point clear? Any doubts, any questions? So this is pod network. So pod network. With the help of this APIs, this Cube API is also a pod. Controller manager is also a pod. HCD is also a pod. Pod means a container. This is also a pod. This is also a pod. So if the API server wants to talk to the scheduler, how will it do this? This is fine, but who is talking and who is actually doing this talking between these two pods? What is the network layer for that? What is the network element for that communication between these two pods? Anyone?
Are you talking about the pod network now?
Kube proxy.
Okay.
Any communication that is happening, any network element that is involved between the communication of any components within the cluster is because of Kube proxy. But Kube proxy is working on which protocol? On which network environment? The kube proxy is working on this pod network. So the pod network is the lowest layer, the network backbone that is provided for all these elements to work. Is that point very, very clear? The network backbone is provided by the pod network. Kube proxy is the network element, which is sort of a protocol between, or the guidelines between how the pods will communicate between each other. That is done through kube proxy. Kubelet is not a network element. Kubelet is a manager of the worker nodes plus the pods inside the worker nodes. So it manages that. It governs. It understands what is the health of the pods. Whether the pod is okay, healthy, or there is some overloaded. The node is overloaded. The node is, it has to be tainted or not, on all these things. So the master node has this Docker to be installed, etcd, API server, scheduler, controller manager. Can you see the controller manager in between the worker nodes and the master node? So anything coming in or anything going out is through the controller manager. But who is doing that activity? It is the API server. And on the slave node or the worker nodes, you have to install Docker, kubelet, kube proxy. That's all. And of course, the pod network, there is another step for the pod network. That is fine during the installation. You do not need to, for each of the slave nodes being added to the cluster, you do not need to do anything with the pod network. Any questions? So the more or less, these are the master and the worker node components. You have already learned that. You have the API server, this is the main component, and this is the Kubernetes cluster. This scheduler, controller manager. See, controller manager is towards the edge between the worker node and the master node, and etcd. So the platform can be Linux, it can be on Windows, but generally you never keep the master node on either Mac OS or Windows, because they are not very stable. Not very stable like Linux. Linux can work. The availability is the most important thing. So to be available, you need some stubborn, some solid operating system called Linux. If you go for availability, it should be availability. It should be available 24/7 into 365 days. No downtime. So platform or the operating system should be US. That's why I have not given Windows. But yes, you can still work on master node on Windows, but that will be a weak architecture, Windows or Mac OS. That is not preferred. You will not do it. You have to use Linux. Any brand of Linux, any distribution of Linux will do. So it is mandatory that you must install Kubernetes master at least on Linux nodes. And generally, companies do what? They have the worker nodes also. Sometimes the worker nodes have to be very powerful, because this is where this is where on the nodes only your applications are going to run. Your microservice applications run on in form of pods. No, those applications never run on this. So sometimes your worker node has to be a bit powerful. Okay, so I will go, or the companies generally go for Linux as well, because here also the question of availability. as you need to have this control plane available 24/7, here also for your mission critical applications, you need to have like the real-time applications, like you are having. Can you think of your mobile switch, or the switch on which the calls, all your mobile calls come and go out? Can you think of even this one going down for 1 minute? If it is down for 1 minute, what will happen? All over India, all over US, all over the world, what will happen? There will be no communication. It's a dangerous thing to happen. So your worker nodes, if there is a real-time mission critical applications deployed over the worker nodes, you need to make them available. Also the same philosophy. So better go for Linux. I will not prefer Windows or Mac. They are good for your front ends, but not working as a backend. You must use these ones. Any questions? So you have HCD. These are the master node components: HCD, API server, scheduler, controller manager. So I will quickly go through this three things or the components. HCD is highly available distributed key value store. Key value store is your database. So it is a database. Or data store, better to say data store, which is used to store cluster-wide secrets. So there is so many informations, and there are few informations which are very, very secretive. It should be only known to the API server, nothing else. Your right hand should not know what is your left hand is doing. It is that private and that secret. So only API server should know. So this information, which is sensitive information, stored over here, should only be available to API server. Nothing, no one else, not even you as an administrator. So it should, yeah, if you are an administrator, you know how to use the kubectl to give specific commands. You can query, but with the help of API server. If API server finds you are authorized, okay, you know the SSLs, you have the security code, you will be able to get the information out of HCD. Yes, that's fine, but not anyone else. It is only accessible by Kubernetes API server. That is what I was saying. It is only accessible. So HCD can be only accessible through API server because it has sensitive information. This information, if somebody, some hacker, that's why you learn after DevOps, you learn DevSecOps, which is a part of cybersecurity. Okay. So if you are a combination of a person who knows DevOps, who knows advanced skills of DevOps like Kubernetes, and then also you know cybersecurity with DevSecOps, you are the most sought after guy in the industry. Many people do a mistake. They learn directly, try to learn directly cybersecurity. So they neglect, or they are not being able to cope up with DevSecOps because they do not know DevOps. But a person who starts with the knowledge of DevOps can easily graduate to cybersecurity. And that is what we are giving to our students. They first come to us, they learn DevOps very nicely, then they graduate, and then this path is so smooth and they really benefit. Therefore, the jobs, even they were not initially when they started with us, they are non-IT guys. They do not have any, most of them, I'm saying all of them, most of them, the students that we deal with, they do not have a very good IT background. But then you will say, if you have a very good IT background, why do you learn DevOps? Yeah, you are very good. The question is very pertinent. But see, okay, I'm talking about the non-IT guys. Let's say we are not dealing with the highly developed IT guys. Okay. But yes, DevOps, though if you are convenient with your development or IT, you have some knowledge on IT, still you will not, you need to have knowledge on DevOps to graduate to cybersecurity, which is nowadays cybersecurity person, if he's only restricted to some pen testing or this and that, will not be sufficient, because for that also the jobs are not easily available. Earlier days it was okay, but nowadays you need to have this vast knowledge of this DevSecOps, and that is quite difficult for someone who does not know DevOps. So this path becomes very difficult or almost sort of impossible. Okay, anyway, so so distributed database HCD is the most important component of master node. All the configuration changes that we are making, all the deployments being created, all the scaling operations being performed, all the details of those are stored in HCD database. All whatever you have done through your deployment is available with each and everything that you do is already recorded with HCD. You cannot escape. So the desired state is stored in the distributed HCD. So whether you want how many pods, replicas, you want 3 or 5 or 7 or 10, all this information is stored over here. So it's stored in distributed etc HCD. It is recommended to have 3 to 5 replica sets of this HCD. So HCD itself can be vulnerable if you have only one. Because as I told you, these are pods, and the pods can happen that in a state of stress, the pod can go down. So if your HCD goes down, if you have only one pod of HCD, what will happen? Will API server be able to function? API server has one pod, scheduler one pod, that is more than enough. But for HCD, I will suggest you need to go between 3 to 5, minimum 3 or maximum 5 pods. That will give you a good, safe and reliable working of the master node. If you have one pod of HCD, one HCD is not a good architectural design. And that is who is doing this cluster. Okay, they will know. Like you will know. You are going to build this cluster. So you will at least have your deployment in such a way that there is at least 3 HCD pods. 3 HCDs. Right? That is what we are saying. Because if one goes down, the other will pick up. Any questions so far? All Kubernetes cluster configuration details, secret keys, passphrase, passwords, etc. are stored in HCD and can only be accessible by the API server. If you know how to access them, if you know you are an administrator, you have the commands, you know the commands, you are entrusted by the company to administer the cluster. So you are a reliable guy. You know the knowledge, you have the knowledge how to extract the data out of HCD. But it has to all come to the API server, because you know your kubectl will only interact with the API server. So you write commands. You say kubectl get nodes. Now this is a command. You press enter. Okay. So you are trying to find how many nodes are there in the cluster. So the result will be, you will be given some details of those nodes on the screen. I'm talking about one of the kubectl commands. Oh, I have not used pen. Sorry. So let me go back. Okay. So all these secret informations are there in the HCD. One cannot access the HCD directly as it is designed in the manner to make the configuration highly available, not allowed to be tampered easily. That is the way it has been designed. Fine. You do not need to take care. Whenever you install Kubernetes cluster, HCD with its own parameters will be set. You do not need to do anything. Now, the next important part is the API server. It exposes Kubernetes API. So all the functions of Kubernetes will be exposed through API server. All the APIs, all the API calls. Basically, these are API calls, application programming interface. You know, because why it is API? Can anybody tell me why it is not native calls? Why you always need to have API calls? Because anyone would like to attempt this question? Why we say APIs every time? When the kubectl interacts with server, API server, you are giving kubectl the command that just now I have said, kubectl get nodes. That command is an API request. Because kubectl is a different component and API server is a different component. You can say these are microservices. Okay, so one microservice talking to the other microservice by making an API call over the network. Everything is happening over the network. So you cannot directly make a native call. It is not a single layer. It is distributed. Therefore, one component talking to the other component has to be through the API calls. Is that fine? So it exposes Kubernetes API. All the functions of Kubernetes is exposed to the API server. API is the front end for all the Kubernetes control plane of the control plane and is used to deploy and execute all operations Kubernetes. You have come to know that. You understand that, right? That whatever happens over the Kubernetes, all the operations are handled by the calls made by API server. So it exposes all the functionality of the Kubernetes cluster. This is the endpoint for Kubernetes service which get exposed for controlling the various API services provided by master node to slave node. So all the services that are provided by the master node to the slave node is through exposing the functions of the cluster through API server. It will control the pods, pod control, deployment, etcd component APIs, all pods information, etcd information access, all the pods APIs are registered to this endpoint. The second most important component is the master node, is the API server, QAPI server. Just can you give me 1 minute? I'm having some nose congestion. I will clear it off. Okay, I'm coming. Can you give me 1 minute, please? I have some congestion. Will that be okay? Just 2 minutes.
Okay.
Yes, I'm back. Okay, so let us continue with our discussion. So we have understood that whatever happens through this is through the in the Kubernetes functions. If anyone has to expose any function, any service to the nodes or to the pods or to the network, everything will happen through the Kube API server. Coming to the next part is the scheduler. It's also a very, very important part. The scheduler takes care of the scheduling of all the processes and the dynamic resource management and manages present and future events on the cluster. So whatever the events will happen on the cluster, that is whether you are deploying a new set of pods or you are replacing or replicating the pods, or you are scheduling some traffic onto a different node, you are taking the pods from a tainted node to a different node. All these activities, all these scheduling activities are performed by the scheduler through the API server. Of course, API server is the control center. Okay, but this scheduler is expert in scheduling jobs. HCD has a particular function which API server does not need to do, but API server will give instructions to scheduler, HCD, controller, manager. Scheduler manages the scaling up of pods. So if I need to make the pod, now I wanted to make the pod from 3 replicas to 5 replicas. Who will take the cluster takes the help of scheduler to do that. It is not the API server or HCD or controller manager. The work is assigned to scheduler. If you want to scale up, because there is a huge traffic and only 3 pods of the same application will not be able to handle it. So you want to scale up, horizontal scaling up of the pods. You would like to do it with the scheduler. According to the application configuration demands on the fly, that is, if an application is running on 5 pods in a VM of 5 CPUs and RAM of 5 GB, where each pod is configured for 1 CPU and 1 GB. So that means you have fully occupied your node. Your node has 5 CPUs and you have 5 pods who requires 1 CPU and 1 GB. So you have basically deployed pods, which is maximum capacity of the node. Then the scaling up of the application for additional 2. Now, those 5 pods are not being able to handle all the requests. So the requirement is to dynamically scale it up another 2 pods. But your system, that node, does not cater because the node has only 5 CPUs and 5 GB of RAM. So will it be sufficient or will it be efficient to incorporate another 2 pods of the same configuration required? That is another 1 CPU and 1 GB. So there are additional requirement of 2 CPUs and 2 GB, at least minimum. So someone needs to look for a VM. Who is that someone? Can anybody now guess? Who is this someone? This is a requirement that has come to the scheduler. Scheduler, because this is the only person out of all other components who can take care of this requirement. That there will be a horizontal, they will need to look for a VM with available resources to create these pods. So out of there are 5 virtual machines, virtual nodes or worker nodes, out of which in one particular node, a particular application has 3 replicas, but it needs 2 more to cater to the traffic. But that particular node cannot accommodate those 2 pods. So what will it do? The scheduler will look for any other node which has enough configuration available in hand to accommodate those 2 pods. So what will it do? It has two tasks. It will try to find out which particular pod, which particular node has that capacity. And then once it locates that, then it will create those two pods. So schedule those, not create, it will schedule. But creation of the pods is a task done by whom? Done by what? Not whom.
Controller manager.
Done by what? Creation of the pods is called like deployment of the pods. Who does the deployment of the pods? You want to deploy your applications over replica sets. So who does it? It is done by deployment, manifest file. That is another object. I will not say component. These are components: schedulers, etcd, API server, controller manager. These are components, but the objects, Kubernetes object is deployment, persistent volume, PV, PVCs, persistent volume claims. These are objects. Then service. Service is an object. We are coming to that part. Okay. So you can create the pods through deployment deployment objects, but with the help of scheduler. So scheduler component schedules the pods to the nodes in the cluster based on the consideration of the health metrics of the nodes. For example, how much CPU, RAM available or storage left? Are there any port conflicts? All these things will be considered by scheduler to schedule a pod over onto a node. Any question? Coming to the controller manager. Today, nobody is asking question. So do I assume that you are fine with the topic, or is it I am going too fast, or the topic is itself complicated? Is there any output? Okay, I will continue. So whenever you get stuck, please let me know. Coming to the controller manager. The controller manager runs all the controllers on Kubernetes cluster. So whatever controller needed, controller is like a program manager within which there are project managers under the program manager. So each project manager does a particular project. So similarly, there are lots of controllers available in the cluster. One is the node controller, one is the replication controller, one is the endpoint controller, one is the service accounts, and other one is the token controllers. So all these controllers are managed by the controller manager. So if you want to do a replication of 3 replica set of a deployment, the scheduler will do it. That's fine. But scheduler will take the help of controller manager. But which controller part of the controller manager? It will call the replication controller. So the controller manager will call the replication controller to do the actual job of creating the replicas. Is it clear? So the controller manager controls all the other controllers in the Kubernetes cluster, node controller, which controls the nodes. So there is a node controller because the scheduler will also need to find out the node. But through what? Through the controller manager. And the controller manager will go and call the node controller. Okay. Node controller, the replication controller, replication of the pods. Endpoint controller exposes the endpoint API services, service accounts, which authorizes users. No, service accounts are very important, security concerns. So somebody is allowed only when the service accounts allow that person to access the Kubernetes resources. Lots of things are there. and token controllers, token authentication. So there are SSL controllers or sorry, tokens and this and that. So many security tokens are there. So who will manage that? To authorize is token controllers. So they are all clubbed into controller manager such that it will reduce the complexity. So you will only see there is a particular SPOC, specific person on call. So I will only, the API server, the scheduler will only call the controller manager. The controller manager will decide which particular person I need to work with. So on the upper level, I do not need to understand each and every details of how the controller manager needs to work. You just give the call to controller manager. Controller manager will know what to do. So the controller manager manages the overall health of the cluster. It controls and manages the desired state versus the actual state in the cluster. So whenever there is a shortfall of the actual state versus the desired state, so the desired state you wanted three replica sets, and actual state says that there are 2 replica sets. So what is the difference? Immediately the scheduler will call the controller manager to ask the replication controller to replicate one more because there is a shortfall of one. So all these things are very orchestrated. They work in like a well-oiled machine. Now coming to the slave node components. The 2 major parts are the kubelet and the kube proxy. You have just now come to know, you have got an idea of what the kubelet does. And you also have an idea of what the kube proxy does. So let us do the kubelet first. Kubelet takes the specification from the API server and ensures that the application is running according to the specifications which were mentioned. So what is the application? Where is the application running? Can anybody help me? Where is your Java application running?
On the slaves, on the pod.
Your Java application is running inside a pod, inside a container. So that is the, so somebody has to be there to understand that your application is running according to the specification mentioned in the deployment manifest file, which is governed by the API server. Are you getting me? So therefore, there is some manager who manages all these requirements. It is very, very strict. If there is some deviation from the specification, immediately it will let the kube proxy know, and the kube proxy will take that information to the controller manager. Controller manager will take that information to the API server. API server will give that information to be stored in HCD. HCD will give back the response saying that no, actually there is one node or one pod short. So immediately that information will be API server will carry to the scheduler. Scheduler will give it to the controller manager. Controller manager will ask the replication controller to take care and replicate one more pod. So this is the way it works. So everything originated from the kubelet. Kubelet is the first person who knows about the health of the node or health of the pod. If everything is, if there is something wrong somewhere. So each node has its own kubelet service. So that kubelet service is also available with the master node, but the main component of the slave node is the kubelet and the kube proxy. So we say the kubelet is the node agent. It works as like an agent. The agent knows the first-hand information. is the component on the worker node. It monitors the activities in the worker node and communicates the health of the node to the master node and more specifically to the controller manager. Got it? Any question? What about Q proxy? This proxy service runs on each node and helps in making services available to the external host. So your services are running where? Your services are nothing but the application endpoint. So somebody is trying to find out a particular application. It has to come through the Q proxy. Q proxy will take your request, make it available to the services, and such that your service will take you to the pod. That is the mechanism. But service cannot take the request directly. It has to come through the Q proxy. So as an external agent, external host, you are requesting for a particular service, like you want to use the cart services of that application, shopping cart. That is an application, that is a service, that is a microservice that is running in a cluster. So you want that. So what will you do? You give a request from outside. But that request will come to the cluster, use the Q proxy. Q proxy will determine where it should go. So it will call that particular service. That service will take you to that application. Okay, so it helps in connection forwarding to the correct resource. You are looking for that resource. Who will do that connection? This is sort of a bridge. That bridge will take your request from one end to the other end through the help of the service object. This is the component and service is an object, like the deployment. We will come to that. Maybe I'm having some issues with my nose getting very choked today. I'm having a bit difficulty in speaking because my nose is choked. Okay, so I will not extend the discussion too much. In fact, I wanted to end my DevOps cycle today with the last discussion on Kubernetes, but since I'm not feeling, I'm not being able to communicate well with my voice getting choked because my nose getting choked. So I will take an apology we'll continue on the next session. Will that be fine? Really, I'm finding difficulty.
Oh, please.
So I will mark it that we were discussing. So let me finish this at least Q proxy, and then we can end the session today. Will that be fine?
Yes.
What do you think? Because I'm physically getting choked.
That's fine.
Okay, I will just finish up that part and we will conclude for today. But we will continue with the next session. So the last part is for today is the slide number 17. So Q proxy enables port forwarding of the service. So a service is over a port. We will come to know what is deployment, what is service, what is pod, and finally the ingress controller. So not much left, but I cannot continue today. So port forwarding of the services to the external nodes or the master. Whenever we are deploying new pods or services, we need to forward the port to communicate to other pods or services, so that these services you cannot understand right now because you need to know about how pods communicate between each other. Okay. And that will be helped only through the Q proxy, because Q proxy is the network element which works on the pod network, the backbone. So that is the external entities can be part of the cluster. So or it will bind. It is doing a binding activity, a bridging activity between all the entities, whether internal or external. Proxy is the network component. Deployments created and exposed as a service is possible for the proxy. So between the pods are like an island. If they are not connected over proxy, they will not be able to communicate between the pods. So your application can only be live and working only when there is a communication between the pods, and that communication is enabled through the network element called proxy. So up to this, I will end today. I'm sorry for not being able to continue, but this much for today. I hope you have understood a bit. Maybe it is a complicated part, not that simple, and it cannot be delivered over a session like this. We need to have a detailed understanding and working. Basically, unless and until we work on the labs, we work practically hands-on. Kubernetes is always, yeah, but if you do not have the theory clear, what we are trying to understand is the theory part, the overview of the architecture. Without that understanding, you cannot do any hands-on. Are you getting me? Why? What is the scope and purpose of this internship session? So I will end the session today. I'll stop the recording. Shubhro, if you are there, can you please also stop the streaming? So can you also stop the YouTube streaming? So thank you everyone for this patience. I know it is not very easy, but thank you for all your patience and your enthusiasm. Thank you and good night, or good. I mean, there will be after morning and afternoons as well. Shubhro. Bye, Shubhro.